Welcome back, welcome back, welcome back. I got on my party hat because we've made it to the end of physical science. Yay! This is our last chapter, and if you're doing this as a class, we're going to talk about acids and bases. Now, the book has 2 more chapters, but they are bonus chapters. You might have noticed before that there's always a couple of extra chapters in the book for if the teacher gets finished early, so that the kids and the teachers don't just look at each other for the rest of the time. So if you have been doing this 1 a week, you will finish this class early. If you've been doing 2 a week, you'll finish about right. But that's up to you how fast you want to do this class. If you have covered all the chapters, you're good. You did it. Yay. So anyway, we have something called standards, and the standards decide what makes up the class. And the last 2 chapters are not in the standards. They used to be back decades ago when I started teaching, but then they went through and they got rid of some stuff that I really like teaching. Part of it is organic chemistry, and I really like organic. So my favorite labs from organic, I sneak them in other places because there's a lot of things in chemistry. I mean, it's not like you can learn other things from it besides the organic chemistry. So my favorite labs I'll still slide over there, but it's not part of the standards anymore, so don't get to teach it. So if you want to continue and learn about this a little bit of organic and biochem and uses of chemistry, you feel free. You just keep on going, but you're going to do it without me. This is the last video. All right? So what are we talking about in this last video? Something that you're already very familiar with, but maybe don't know quite the terminology. Acids and bases. What's an acid and what's a base, and what is it? Well, in general, acids taste sour. Not that we're supposed to be tasting things in chemistry. That would we won't get superpowers, I know. But you do taste acids all the time. Orange juice, vinegar, soda, things like that are all acids, meaning like Coca-Cola, RC Cola, Pepsi Cola. I found a new soda I really like, Dr. Brown's Black Cherry Soda. It's very delicious, but I digress. So acids, they feel like water. So like if you think about how they feel, they're not, they just feel watery. They taste sour. There are certain things called indicators, and they change colors in the presence of an acid or a base. And there's one very famous one called litmus. And acids will turn blue litmus. They call it red, but it's really pink. It turns pink. This little light blue strip will turn pink when it's dipped in an acid. Some strong acids are corrosive. They can be dangerous. And some of them are not dangerous at all. I mean, you don't think, oh no, orange juice, unless maybe it gets in your eye, right? Then you might say, oh no, orange juice. But those are some common acids. There are other things like battery acid in a car is a very strong acid. Hydrochloric is a very strong acid, and they can be very dangerous. So, and then other acids are called weak acids, and they're not so dangerous, and they're important. They're important to our food groups and for cleaning things. Vinegar is used for cleaning, so all of those are important. Now, the opposite, let me also say, there are other indicators besides litmus. Sweet tea or any tea. If you take tea and you squirt lemon into it, it goes from a darker brown to a lighter, more yellowy brown. That's not from the lemon, it's that tea is an indicator and it changes colors. Another one is cabbage juice. You can take purple cabbage, red cabbage, cook it, get the juice, it's this purple colored juice, and add acids and bases to it, and it turns colors. So that's what I want you to do for your lab this week. I want you to test different acids and bases and see what colors they are. There's a lab that goes in our book that you can get some ideas of what to test, but you can go beyond that. And you can also Google it and look at cabbage juice acid-base labs, and they'll give you ideas of what to add. But the cabbage juice works great. It doesn't just get a little light like the sweet tea. It turns really pretty colors. There are other ones you'll use in chemistry class. There's one called phenolphthalein that turns bright pink in the presence of a base. There's one called universal indicator that is a lot like the cabbage juice. It turns all different kinds of colors, pretty colors, from whether it's in contact with an acid or a base. There's one called hydrion papers. They're yellow papers that turn colors, where litmus is just red or blue. And so anyway, those are indicators, things that change colors depending on whether it's with an acid or a base. So what's a base? I keep talking about them. Bases are the opposite of acids, that they feel slippery. So this is soap, ammonia, detergents, things like that. A lot of cleaners are bases. So they feel slippery. They taste bitter. You can always think about the Christmas Story where the boy's got the Lifebuoy soap in his mouth and goes, "Ugh, Lifebuoy." Bleh. My parents never did that. They never put soap in my mouth for anything like that. But I've heard of parents who did it. Maybe yours do. I don't know. Is that an old-timey thing that people don't do anymore? I don't know. But I didn't do it to my kids, and my parents didn't do it to me. But I know it happens. I've heard people putting a hot sauce on the tongue, too, of kids who say bad words or whatever. My parents didn't do that either. I don't know that I really said bad words much. I don't. The reason why is I am just not aware enough to say bad words. If I did, I would say them at a time that's inappropriate. I have no filter and I can't turn things on and off. What you see is what you get with me. So I have to make sure I don't ever say bad words, because if I did, I would say them at the wrong time. Where other people, to tell you the truth, there are some teachers I know who, when no children are around, woo, they could let some bad words fly. But they would never say bad words around children. If I said bad words, I would end up saying them around the children. I just know. So I can't say those, no words like that at all. So anyway, I don't know how we got off on that. Bases. Oh, Lifebuoy in your mouth. They feel slippery. Now, people will say acids are dangerous and bases are not. Strong bases are just as bad. A long time ago, when I was teaching in Mableton, Georgia, there was a chemical attack on somebody. People are evil and will sometimes throw chemicals on an enemy to hurt them. So there are parts of the world where, like if a girl rejects a suitor, someone who wants to date her, then like they will throw acid in her face and melt her face. Or and I've heard that that's starting to be more common here in the United States, so watch out for that. But anyway, there was a chemical attack like that in Mableton where I taught, and in the newspaper article it said that there was an acid attack in Mableton, and that somebody poured acid in someone's face, but they got to the doctor on time, and like sometimes it'll make them go blind and stuff. But then the last sentence of it said that they thought that the acid was lye. Well, lye is a base. It's corrosive, and it's not that acids are not corrosive and bases. Acids are corrosive and bases are not. It's the strength. If it's a strong acid, it can be very corrosive, like hydrochloric, sulfuric, nitric acid. All of those are very strong. And on the other side, the very strong bases can also be very corrosive. So it wasn't, even though the newspaper article said acid attack, it was actually a base attack, according to the article. So there you go. And let's say something else about this while we're on the subject. I don't know if y'all realize this, but there's a lot of misinformation on the internet. I know, it's shocking. I used to spend too much time on Facebook, and one time I was scrolling through Facebook, should have been probably doing something else, and I kept seeing this post that people were resharing, and it was that you need to be eating foods that are basic and not acidic. Acidic foods are bad for you. You should have basic foods, and it would say you should have basic foods like, and it had this list of foods. Well, half the foods in that list were acids. It had like tomatoes. Tomatoes are extremely acidic, especially can be really acidic here in Georgia where we have clay for soil. So it was just so irritating. I'm like, why would I take any diet science advice for you when you don't know the difference in an acid and a base? So anyway, don't believe all the health things you read on Twitter or Instagram or Facebook. They have some misinformation on there, especially when it comes to science. I just say, don't get your science from Facebook. And I'll see this stuff that's wrong all the time. And, you know, part of me wants to correct it and say, you know, that's wrong or whatever. And I used to, but now usually I'm just like, just keep scrolling, don't say anything. They don't really want to know. But one time there was a nurse who was a friend of mine who had put something up that was wrong science. And I didn't put it on her, I didn't write her right back, but I messaged her. I said, you know, this is wrong. She said, yeah, I know, but I was just trying to manipulate people's behavior. You should not use science to manipulate people's behavior, especially when it's not true. But anyway, all right, so acids and bases and indicators, we talked about that, common bases. You will be able to read more about that in your book, but there's a lot of them. Ammonia is a common base. All right, so solutions of acids and bases, if you have, like say you have hydrogen chloride, when it gets in water, the hydrogen comes off and the chloride comes off and it disassociates completely. They don't stay stuck back together again at all. When acids and bases disassociate completely when they're in the water, they are strong acids and bases. When they only partially disassociate, they're weak. So hydrochloric acid disassociates completely, but something that is a weaker acid or base does not. So the more disassociation, the more it comes apart, the more that it is acidic or basic in strength. Now, you can in general think that acids have hydrogens in them. They're hydrogen donors. They have hydrogens floating off into the water, and they're charged hydrogens, so they're really just protons, and that makes it acidic. The more hydrogens, the more acidic. And in general, the bases are things that have OH. It's called the hydroxide ion. It's a polyatomic ion. Remember, I told you there are elements that bond covalently, they share, but then together they act like an ion, either having a positive or a negative charge. So the OH has a -1 charge. It's called the hydroxide ion, and the more of that that's in something, the more basic it is. Now, there is way more to it than this, because there's things like ammonia that doesn't really fit. So there are different definitions of acids and bases, but this is just in general. And then think about it, that water is H2O. It's one H joined to an OH. So water is half acid and half base. It's neutral. It's neither. It's in the middle. So there you go. We talked about the strength. We talked about concentration. The more concentrated it is. Okay, now, how do we report how strong it is? We need a way to measure it. Well, it's something called pH, the pH scale. When I was a kid, they used to do a lot of advertising about pH on TV about shampoos. They'd say the shampoo is pH balanced to make your hair all pretty. So there was a lot about that. So we kind of knew a little bit about pH, but I don't know if you do or not. But it's how the acidity or basidity is measured. The closer it is to 0, the more acidic it is. So things like hydrochloric acid would be like a 1. And then as it gets further and further from 0, it gets less acidic until it gets to 7, and 7 is neutral. That's where water is. So an acid that has a pH, let's see what, we got a little chart in the book. It says tomatoes are between 5 and 6, so those aren't too dangerous. That milks are about 6. That vinegar is about 3.5. Soft drinks are more like 2. So the more acidic it is, the closer it is to 0. When it gets to 7, then it's neutral, it's water, or has the pH of water. So those shampoos back when I was a kid were pH balanced. That means that they had stuff added to them where they weren't real basic like how shampoos normally are. They had some acid added to them, so they were closer to pH of 7 of water. Then as you keep going up, then it's basic. So like milk of magnesia, that medicine you take if your stomach's upset, that is at about, it says at 9, Baking soda is about at 10. Ammonia, it looks like, is at about 13. And then Drano is an extremely strong base. It's almost up at 14. So, and that is very dangerous too. I knew a girl in elementary school who, when she was born just fine, beautiful little girl, but her parents had not put the locks under the cabinet, and they had chemicals under the cabinet. And I think she, as a baby, like a 2-year-old, went under the kitchen sink, got the Drano, and drank some of it, and it messed her up. She was not smart anymore. She was very beautiful, but not smart. And she would have been smart, so it was real heartbreaking. So just moral of the story, always keep chemicals away from children, because children just don't have any sense, and they'll eat stuff and drink stuff that is harmful to them. Now, blood is very close to neutral also at 7. Now, what happens if you add an acid and a base? I always ask this to kids, and they always say, an explosion. No. If you add an acid and a base, what you get is a neutralization. They counterbalance each other, and you get salt and water. Salt water. Not very exciting at all. So if you add a strong acid, a strong base. Now if you add like a strong acid and a weak base, you'll get a weak acid. So it's sort of a sliding scale there. So what if someone throws a chemical in your face and you are a victim of this crime? You need to think very quickly, is it slippery? If it's slippery, it's a base, and you need to put an acid on it, a gentle acid as quick as you can. You can pour a soda on your face, vinegar, orange juice if it's slippery. Okay, and then get to the hospital as fast as you can. But try to neutralize it as much as you can before you get to the hospital. If it feels like water and it's not slippery, then it's an acid, and you can put a base on it really quickly. Baking soda, something like that would just neutralize it very quickly. In lab, we would keep Diet Coke in cans. We'd buy the cheap brands, the Kroger brand of it, whatever that is. So that if we had a base spill, we would just pour Diet Coke on it. Now, why do we do Diet Coke? Because it's not sticky, like it didn't have real sugar in it, and it was easier to clean up. And then when you put kitty litter on it, and then you sweep it up and throw it away. And then we would also have some base things that we could neutralize an acid with, and not just clean it up. We would neutralize it first, and it made it safer. So there are other things you'll learn about in chemistry. There's something called a titration. I'm not even doing a titration with my chemistry kids this semester, though. They kind of frustrate kids, and so I'm going to let them wait till college or AP Chem to do that, or Chem 2. Regular Chem, because of COVID, we don't have time to do everything, so we're not going to do titration. Some teachers love titrations. But what you do is you have one chemical in your flask or beaker or Lemire flask at the bottom, another one in a tall, skinny tube called a burette, and then it's got a little turner called a stopcock that you turn that lets the fluid out. You go like, and it stops it, and go like this, and it comes in. And you add a little bit at a time until you get a color change. Like a lot of times it's the phenolphthalein, the hot pink. And when you get that color change, that means that you have just reached the point that you needed to for the chemical reaction. So it's an important thing, but kids get so frustrated at it. They'll be like, nothing. Whoops, too much. Got to start over. Now, how does soaps and detergents work? How this works is they have a polar end and a non-polar end. So if you've got some dirt on you, it is usually oily dirt, okay? So then the soap molecule will come, and the non-polar end will stick in the oil. And it has another end sticking up that is polar. And then you wash it, and then the water comes by and grabs the polar end and pulls it away. So it like fish hooks the oily dirt off of you. So you can read more about that in your book, or Google it or whatever. And there is a difference in soaps and detergents, but that's just the basic idea. One time while I was teaching, I taught this, and I had this girl say, Miss Blackburn, I never use soap. I just get in the water and let it wash over me. And I was like, don't know if you're getting clean, but I also know that our bodies are pretty amazingly made, and they do have sort of self-cleaning parts to them. And I know also that you can overwash, where you end up drying out your skin and taking away the protective layer, and then you can have, you know, dry skin and cracked skin and all that. So I'm not judging her. I'm just saying it was interesting to me that she never used soap, and she didn't seem smelly to me. So I'd like to know more about this no soap cleaning method. It sounds cheaper, doesn't it? Okay. Let's see. I think that is it. Yay! We did it! We talked about everything that we're going to in the book and in physical science. Studies show that if you take physical science, you do better in chemistry and physics. So I hope you've enjoyed this little touch into physical science. I think it's a great class. I think you have a very good and interesting book. You should finish reading it and come back for another class. I'm glad you were here. Come back again, like, share, subscribe, and remember, science is great. Yay, we made it.